Greetings of the day. In this session we are going to discuss the impact test on mild steel, aluminum, brass by means of CHARPY test, AIM. To determine the impact strength of mild steel, aluminum, and brass of given specimen by CHARPY test, apparatus, pendulum-type impact testing machine, vernier caliper, reference. CHARPY introduced CHARPY test in 1909. Test is as per the Indian Standard, 1499. Theory. In an impact test, a specially prepared notched specimen is fractured by a single blow from a heavy hammer, and energy required being a measure of resistance to impact. Impact load is produced by a swinging of an impact weight W hammer. From a height h, release of the weight from the height h swings the weight through the arc of a circle, which strikes the specimen to fracture at the notch in that kinetic energy of the hammer at the time of impact is mv squared divided by 2, which is equal to the relative potential energy of the hammer before its release. And where m is the mass of the hammer and v is equal to 2g is its tangential velocity at impact. G is gravitational acceleration, 9.806 ms2, and h is the height through which hammer falls. Impact velocity will be 5346 ms or slightly less. Here it is interesting to note that height through which hammer drops determines the velocity, and height and mass of a hammer combined determine the energy. Energy used can be measured from the scale given. The difference between potential energies is the fracture energy. In test machine, this value indicated by the pointer on the scale. If the scale is calibrated in energy units, marks on the scale should be drawn keeping in view angle of fall and angle of rise. Height hon and h2 equals honais equal to r in bracket on m minus cos theta, and h2 is equal to 1 minus cos theta. With the increase or decrease in values, gap between marks on scale showing energy also increase or decrease. This can be seen from the attached scale with any impact machine. Energy used in fracturing the specimen can be obtained approximately as 1 minus watt 2, this energy value called impact toughness or impact value, which will be measured per unit area at the notch. CHARPY introduced CHARPY test in 1909. Test is as per the IS, 1499. Mounting of specimen is tested as a beam supported at each end. Hammer is allowed to hit then specimen at the opposite face behind the notch. Procedure. 1. Measure the dimensions of a specimen. Also, measure the dimensions of the notch. 2. Raise the hammer and note down initial reading from the dial, which will be energy to be used to fracture the specimen. 3. Place the specimen for test and see that it is placed center with respect to hammer. Check the position of notch. 4. Release the hammer and note the final reading. Difference between the initial and final reading will give the actual energy required to fracture the specimen. 5. Repeat the test for specimens of other materials. 6. Compute the energy of rupture of each specimen. These are the observations. Weight of hammer, that is W equal to 20.87 kilograms length of hammer, that is R equal to 0.8. 25 m, angle of fall alpha, equal to 140 degree. Area of specimen below the notch, which is equal to 6 millimeters multiplied by 9 millimeters, equal to 54 millimeters square. An observation table shows that different materials such as steel, aluminum, and brass, angle of fall, initial reading and final reading, energy absorbed, impact strength, angle of rise, and impact velocity, and sample calculation. For steel, impact strength equal to energy absorbed divided by area below the notch equal to 184 by 54 equal to 3.47 joule per millimeter square. For aluminium, impact strength equal to energy absorbed divided by area below the notch equal to 56 by 54 equal 1.037 joule per millimeter square. For brass, impact strength equal to energy absorbed divided by area below the notch equal to 38 by 54 equal to 0.703 joule per millimeter square. Sample calculation. For steel, impact energy equal to WR QA's beta minus cos alpha, 184 equal to 20.87 into 825 QI's beta minus cos 140. After calculating, we get beta value, which is equal to 39.1 degree for aluminium. Impact energy equal to WR QOS beta minus cos alpha, 56 equal to 20.87 into 825. Coas beta minus cos 140. After calculating, we get beta value, which is equal to 39.74. For brass, impact energy equal to WR QOA's beta minus COA's alpha, 38 equal to 20.87 into 825, POW's bot minus CO's 140. After calculating, we get beta value, which is equal to 39.82. The formula for impact velocity is under root 2gr in bracket 1 minus CO's alpha, and after calculating, we'll get impact velocity equal to 5.346 meter per second. Finally, we will get the results in form of impact strength of different material. First, impact strength of steel specimen is 3.407 joule per millimeter square. Second, impact strength of aluminum specimen is 1.037 joule per millimeter square. And third, impact strength of brass specimen is 0.703 joule per millimeter square.